Welcome back, dear class. In today's class, we will cover a beautiful concept of Java interfaces. This is second part of this chapter. We have already covered packages. The last topic that we saw in packages, it was importing the packages. Now we shift our focus towards the next concept in chapter, which is about interfaces. Now interfaces, they usually it's another way of abstraction in Java and polymorphism in Java. You remember in our very first class we discussed that there are three basic principles of object-oriented programming. Those are encapsulation, polymorphism and inheritance. We have already covered all three. And then the fourth, which is loosely coupled principle of OOP, they say, some books say it is the fourth principle, some say abstraction is possible even without object-oriented programming. So usually they say it's a weak fourth principle of object-oriented programming, which is called abstraction. When we discussed about abstraction, we say that we usually we tell people what to do, and how to do, we leave it on the people. You remember I gave you example in class when you were here. I told you that inside a car we say here is a steering, and we say that steering is to move, to steer your car to left, right, straight. So you have been told that what you need to do with the steering. But how actually steering is working behind the scene, that's none of your business. Because if you start thinking on that, if you open the car and then try to find out, like Rancho of Three Idiots, that how actually car is steering on left and right when we steer the steering, obviously you won't be able to drive the car. So abstraction in real world, it's a very important concept. We usually say you must be concerned with the what to do and forget about the details. Details are actually responsibility maybe of another guy. Similarly, in our homes we know that we have got these brick walls, we have got doors, they are all standing. You have to live in the house. It's none of your business how these walls are standing, why they do not fall. If you start thinking on those, probably you will destroy your home and you won't be able to enjoy living in that home. So abstraction is a very key concept in real world. So Java implements abstraction. One way we have already seen when we were covering abstract classes, when we were covering abstract methods. And those methods, you remember, we used to say here is the method definition, and we never gave complete implementation of the method. We just say if you want to be an animal, you need to have a sound, and then that sound method was without any body. You know that those animals which are actually animal, like we had cat, we had dog, they are going to implement the sound. They are going to tell you what is the sound of cat, what is the sound of dog, sound of horse, and so on. Right. So this abstraction thing, which we were already doing with the abstract classes, can also be achieved by using interfaces. And these interfaces can also help you achieve polymorphism, which is actually dynamic method dispatch. We have already seen that how a base class reference can store object of the derived class, and then how base class reference can be used for dynamic method dispatch. I'm sure that you are clear with the concept, but if you are not, then you will have to see my inheritance lecture from the previous chapter, from the previous week. Right. Okay. Now, there is a difference in abstract classes and interfaces. In abstract classes, you can have abstract methods as well as methods with bodies. But when you talk about interfaces, then in interfaces, there cannot be methods with bodies. There are only methods which are abstract, which do not have any body. Although after JDK 8, Java has came up with an idea of default method implementation, but that is actually not the soul of the interfaces. The soul of the interfaces, it should give you abstraction, it should give you what to do, and how to do is left on the classes which are going to implement those interfaces. right? You can declare an interface with the keyword interface, and obviously in Java we have discussed in our last Zoom session that Java does not allow multiple inheritance. I mean, it is not possible to have a class which extends from multiple classes. That is not possible. For example, if you have a class, say for example, if you say class A that extends B, that's fine, but you cannot say that also extends C. This is not allowed in Java. This is not possible in Java. I mean, one class can be extended from only one class. It is not possible to have a class which is extended from multiple classes. It is absolutely not possible. I mean, Java gives a very simple reason. Java says because in real world your classes are driven mainly from one class, so why in programming world you should bring a kind of facility which says one child have got multiple parents, right? Okay, so this is not possible, but Java says if you want to have multiple abilities inside one class, and you say those abilities are coming from varying backgrounds, then those abilities should be declared inside interfaces. A single class can implement multiple interfaces. A single class, though, cannot be inherited from multiple classes, but a single class can implement multiple interfaces. Don't worry if you do not understand this concept at this stage, because as we move along we'll see examples, and then this concept will be very much clear on you, right? So if you want to declare an interface, this is how an interface is declared. Inside an interface you will have two things. It is very much like class. You know that in class we can have methods and we can have variables, I mean member variable. Same goes true with interface. In interface you will have methods, but the difference is methods must not have body. You can see here these methods do not have any body, and additionally interface can also have a member variable. And remember, member variable inside interface are final. When you say they are final, it means you cannot change their values when you go inside class, right? So you declare an interface by using the keyword interface, and then here has to be the name of the interface, and this has to be access modifier. And access modifiers are usually, public and default. You know that if they are public, then they are accessible outside the package, but if they are default, then they are accessible only inside the package. We have already seen access modifier in our previous lecture, right? So these are the changes that JDK 8 brought in interfaces. As I told you earlier, they actually came up with the default method implementation. We'll see this at the end of this lecture, and then they have also introduced the concept of static interfaces. We'll also discuss this concept. And JDK 9 even introduced private methods inside interfaces. We will also discuss this concept. As I told you earlier, when you are defining an interface, variable inside interface are final and they are static implicitly, right? And all the methods and variables are implicitly public. So when you implement a method in class, it must be public. I mean, you cannot have a private method because these methods are meant to be called outside the class. So you cannot make a method private, because if you remember, we know that if we have got a method in the base class, and if it has got an access modifier, and when you extend a class from the superclass, then the method which is declared in the superclass, when you override it, then your class can have less restrictive access modifier, not more restrictive access modifier. So obviously same goes true in interface. If inside interface you have got a public method, you really cannot make this public method as a protected or default or any other access, because if the method is defined in interface as a public, you cannot make it more restrictive, right? Okay, now implementing an interface is actually by the keyword implements. We'll see it. And then multiple interfaces can be implemented by a class. As I told you earlier, a class cannot be inherited from multiple classes, but a class can implement multiple interfaces. Right. You will get this whole idea by seeing an example. So let us see a simple interface definition and see how class implements that interface. Okay, so remember, when you declare an interface to be public, then you will have to save that interface inside a file with the name of the interface. So I can write here, say for example, public interface animal. Right, I say that I'm going to create an interface. This is the keyword interface, right, and this is name of the interface, which is animal, and the actual modifier for this one is public. And as I told you earlier, if your interface is public, then it needs to go inside a file name whose name is same as the name of the interface. It means this must be saved inside. Maybe I can write here interfaces, right. We'll be saving today's code here. So animal.java, right. Now, as I told you earlier, when you are declaring an interface, you are actually kind of creating a map how an animal looks like. What are the requirements for an entity to be an animal? It is just like when you create an interface, you are actually creating a skeleton for a class. You are kind of creating a map for the building, right? When you create a map for the building, map is just like interface. You define that inside the building there will be 5 rooms, there will be 1 kitchen, there will be a drawing room, all these things which you define in the map, you are creating a kind of interface for the building. So same goes true for an animal interface. So you know that if an entity wants to be animal, then there are certain requirements, and one of those requirements is an animal must have a sound, right? So the example that we saw when we were covering inheritance, the same example I continue when we are covering interfaces, right? So we say that all the animals should have sound. Now what sound, exactly which sound, we cannot explain because we don't know which animal we are talking about. So here at this stage, the sound method need to be abstract because we don't know which animal we are talking about, right? So here I say public void sound, right? That's all. This is your abstract method. Remember, inside interface you really don't need to give body of the method. All these methods which are declared inside interface, they are abstract. They are by default abstract. You can see here I did not write a keyword abstract. I don't need to write it because by default this method is abstract. You don't need to really make it abstract. By default they are abstract, right? So I say for an animal to be animal, it has to have a sound, right? And then for an animal to be an animal, it need to have some food, right? And that's it. So inside this interface we have got nothing, just 2 methods which are abstract method, which are actually kind of explaining what actions an animal should be able to perform, right? What I'm going to do, I need to compile this command prompt. Okay, save as animal. I copy this path. No, right. Okay, I copy the path. Now I say cd to this. Yes, javac animal.java. So you can see my interface has been compiled, right? Now what I'm going to do, I'm going to create a class which is going to implement this interface, right? So I say public Kate, right, implements animal. right? It means that I'm going to create a cat, and when I say implements, and this is the keyword implements, right? So you can implement an interface by using keyword implements. Now remember one thing, when a class is implementing an interface, then it is responsibility of that class to give implementation of all the methods that are declared inside that interface, right? It is just like you lay out a requirement for an entity to be animal. You declare this interface and you say that if you want to be animal, then you have to have these actions. You have to have a sound and you have to have a food, right? It means that now when you implement animal inside cat, then cat is supposed to implement these two methods. Remember, if cat does not implement one or both of these methods, then cat cannot be compiled unless cat itself declares itself as an abstract, right? I come back to this point later on, but for the time being, let us see that I have created a cat class, right? A cat.java, right? A cat class, and it is responsibility of the cat to implement sound as well as food. So I can write here public sound, right? You need to write the return type public void sound, public void sound, right? And then system.out.println, you know, sound of the cat, meow. Okay, and then here public void food of the cat, you know that system out println cat drinks milk, right? That's milk. Okay, so now I can compile cat. I can now compile cat java c cat dot java public okay, it has to be a class, right? Okay, java c, you can see it has been compiled, right? Obviously I cannot run it because I do not have any main method inside this. Let's see if I do not implement food, right? As you can see, I have partially implemented animal. When I say partially, I mean that inside animal I had two methods, one for the sound, one for the food. I gave implementation for the sound, but I did not give implementation for the food. Compiler will complain. Compiler will say, because inside animal you have got two abstract methods, you are implementing one, you also need to give implementation of the second method. So you can see here, this time compiler will complain. Save. Right, so you can see compiler is complaining. Cat is not abstract and does not override abstract method food, right? The concept is very much clear. Now if you want to be cat, if this class want to be animal, then it has to implement all the actions that animal is defining, right? And if you are partially implementing, then this class has got another option, that this class itself should be abstract. So you can make this class an abstract, then it is fine. If it is an abstract class, then it makes sense. Now you can say that in this abstract class we have got one method which is implemented, and there is another method which is an abstract method which is coming from the animal. So obviously in this case it will be compiled. Now it will not complain. So you have got two options. Either you make your class abstract and then you can partially implement the interface or not implement the interface at all, or you have to override all the methods that are coming from the interface, in this case which is the animal, right? So what I'm going to do, I remove this and I implement my interface fully, right? So this is food, public void food, it is milk. Okay, so our cat has been created, java c, right? What I'm going to do, I'm going to have a cat dim, right? Or maybe here I can write not a cat demo but an animal demo, right? So I say a class animal demo, right? Inside this class public static void main string arg, right? So here I'm going to create a cat c equal to new cat, right? Now you know that I can write c dot sound, it will display the sound, and c dot food, this will display the food, right? So I'm going to save this animal demo. I can make it public, right? Okay, so animal demo dot java, right? So I come back here, cls java c animal demo dot java, okay, java animal demo. So you can see meow and milk, right? Similarly, what I'm going to do, I create another class, and this time public class dog, right? And this implements interface animal, okay? Now because this implements interface animal, so it is the responsibility of dog to give implementation for the methods which are inside animal. I save it with the name dog.java. Obviously if I compile dog.java, it will complain. You can see dog is not abstract and does not override abstract method food in the animal. So obviously it is complaining that inside animal whatever methods you have, you need to give their implementation. In this case it is sound and food. So obviously dog also needs to implement both of these two methods. So public void, let's change this access modifier, void sound, and you know the sound of the dog, system system.out.println how, right? Okay, and then I also have void food, we say that dog eats meat, right? Meat, bread, whatever you give to the dog, right? Let's see what happens. So now if I compile dog, you can see food cannot okay, in dog cannot implement food in animal, attempting to assign weaker access privilege was public, and sound, right? So this is the problem that I was mentioning you earlier. Remember, inside animal you declared these two methods as public. Even if you do not declare them public, they are still public because by default they are public. You save them, I compile animal, right? Java C animal dot java, right? And now if you compile this one, you can see they are still public. So you declare them public or not, they are public. And we have seen this rule of access modifier. We say that if you have got an access modifier in the superclass, and if in the derived class you are going to assign it a more restrictive access modifier, it's not allowed, right? So you can see here, because this is public here, now when you are implementing it inside dog and you are making it default, it means default is more restrictive. So you cannot obviously assign more restrictive access modifier in the derived class, right? Because dog is in a way is driven from the animal, though animal is not a superclass, but it is an interface, so it has got equal prestige as the superclass. So obviously here you need to declare them public. You must understand this concept of choosing appropriate access modifier. If you choose wrong access modifier, obviously your code won't compile, right? So now this should be okay. Java C dog has been compiled because we make these methods public. Okay, so we say we have got now two classes. One is Kate, which implements animal, other is dog, which implements animal. Right, now see the interesting fact. I come to animal demo. Inside animal demo, now I say dog d equal to new dog, right, and then I say d dot food and then d dot sound. Absolutely perfect, right? I now compile animal demo, Java C animal demo dot Java. It has been compiled. Java animal demo. You can see here meow, milk, how, meat and bread. Right, perfect. So in this simple example, we created an interface animal, and that was implemented by Kate, and that was also implemented by dog, and then we saw a demo in which we created object of Kate and object of dog. Okay, now remember one thing, it is absolutely not required for Kate to have only methods which are which are coming from animal. I mean, Kate and dog, they are completely free to define their own methods. And the methods which are not defined in the animal, but they can define their own methods. For example, it is completely fine if I have, say for example, public string to string, right, and then I return food plus, I cannot, food, maybe to string, let's do, no, return, this is a Kate object, right? So you can see here this toString method is an additional method that we are going to override from Java.lang.object, right? So it is absolutely fine to have more methods in a class which are not declared in the interface which it is implementing. But the important thing is the minimum requirement for the Kate is to implement those methods which are coming from animal. And then after implementing those methods, it is up to Kate to introduce more methods like toString in this case, right? So I save it, I compile Kate. You will see that Kate will be compiled without any issue. So it is compiled, right? And then inside animal demo here, you know that if I system.out.println C, you know that this will by default call toString method. We have already discussed this concept that when you print a reference of a class, then inside that class object the toString method will be called, right? So this statement should actually display this output. This is a Kate object. Let's check it. Java C animal demo dot Java animal demo. So you can see here this is a Kate object. This method has been called when we printed reference of this class. Okay, so this was the basic simple interface definition and class implementation. I end this lecture here, and when you come back we will see polymorphism in action by using interfaces. Previously we saw polymorphism in action by using super and subclass concept, by using abstract classes, but this time we'll see similar implementation by using interfaces. Thank you very much.